and welcome back. And today we're back to working on the Centurion. Although, if we're being honest, the Centurion itself doesn't actually need any work. The computer portion of it has just always been rock solid and working perfectly. But a computer is largely useless unless you have a data storage solution for it. Just ask all the people that have been buying the Nabu 8-bit home computers recently. That is a very cool machine, but without a storage solution, it makes life very difficult. But for the Centurion here, we do actually have data storage solutions. They're just all in the form of CDC or Control Data Corporation made drives. The first drive that we restored was the Hawk drive here. This is a essentially bleeding edge technology hard drive from about 1978. It has a 5 megabyte fixed platter and a 5 megabyte removable platter. And getting it going had its own trials and tribulations, but once we got it going, we found the operating system as well as a bunch of other really cool stuff. And being able to get into the operating system was absolutely mega. It really opened the door for doing a lot more really interesting things with this machine. But once the Hawk drive was up and going, it was time to start working on the next drive. And that required working on the FFC, or the Finch floppy controller. And well, I didn't want to risk the Finch, so we started on the floppy drive. Again, a CDC made 8-inch floppy, and boy, that one just really almost broke me. I spent so much time working on that floppy drive, and it took no prisoners whatsoever. In many ways, it was actually much more difficult to get the floppy going than it was to get the Hawk drive going. But we got it going, and we were able to get it to be seen by the operating system. We were able to write files to it, read files from it. So now it's time to move on to the next CDC made drives that we have. There are 2 drives left that I need to restore. One is the Phoenix drive, which when we're talking bleeding edge, it is the quintessential definition of bleeding edge hard drive technology. And as such, I don't know if we're going to be able to get it going or not. So we're kind of saving it for later, which leaves us with this drive right here. Again, Control Data Corporation made. It is the Finch drive, and this one holds 32 megabytes, but it's completely sealed. There is no removable media. It's actually much more similar to a modern hard drive. So what I want to do today is start testing and potentially troubleshooting the Finch drive here, because we are fairly confident that the FFC card is working at 100%. There might be some bad chips for just the Finch portion of that card, but you know, we really think that it's doing what it's supposed to do. And so that might mean that we have a fault on the Finch drive itself. And given my history with CDC drives, if this one is going to put up as much of a fight as the floppy, it might well break me, because it is orders of magnitude more complex than the floppy was. But we won't know until we try, and I'm certainly not going to go down without a fight. So let's get this thing plugged into the machine, start turning all the switches on, and at least get a baseline. Let's see if it is still failing the read test in the same way that it was before. So let's get started. I've got my fingers crossed that something good happens today. All right, let's get this thing booted up. We'll start by turning on the main power here. That's going to turn on the cooling fans to the Hawk, but we're not going to use the Hawk. We'll turn on the CRT up here, turn the computer itself on, hit reset. We are in test 0D on the diag card down here. The CRT should be warming up. Yep, we can see our all auxiliary tests list there. So next, let's kick on the power to the Finch drive. And I've got it on its own separate little switch here. So we'll flip it. The Finch drive is spinning up. That's good news. We should see the heads do a test seek here. Yep. There we go. It did a couple of seeks back and forth. Sounds like it's ready to go. So we'll do the Finch read test, which is... Oh, no. Well, that didn't go as planned. So what just happened? It spun up, it sounded totally normal, right up until it didn't. It made a horrific sound, like a screeching sound, and then it settled into just a bad sound, and then I powered it down. And that was totally unexpected. And it's unexpected for a reason that's not immediately apparent when you're watching these videos. And that is, before I even turn the camera on for the first time, I often double check or triple check things. I'm kind of pulling the veil back on the movie magic that goes into making these episodes. So today, before turning this thing on, I knew what was going to happen up to a certain point. I knew that it was going to spin up, it was going to do its head seek self-check, then it was going to sit at track 0, and I was going to run the read test, and it was going to fail with busy did not clear. I knew all of this because I have spun this thing up multiple times over the past week, getting scope shots and building the narrative in my head so that I can bring you guys along on a more tight, concise story of how the troubleshooting went. And well, throughout all of those power-ups, it had never made that sound before. That was truly the first time I've ever heard it do that. Worst case scenario, we had a head crash. And well, if we have a head crash, that's it. This thing is pretty much unsavable. The other path, if we get lucky, is that maybe the bearing is just starting to dry out and we're hearing it make some funny noises. And well, this drive spent its entire life sitting on its side. Now, the CDC manual says you can power it up on its side or on its back. I feel much more comfortable powering it up on its back because when it's on its side, it's super unsteady. It's really easy to knock over. So to make sure that I didn't accidentally bump the table while filming and send this thing toppling off, I powered it up on its back, which I had done multiple times before. But it's possible that all those years of being on its side wore the bearing into kind of a groove, and by powering it up on its back, I've forced grease out where it's not supposed to be, and now the bearing is having a rough go of it. Unfortunately, there's not really a great way to tell without taking this thing very far apart. But before I do any of that, I need to talk to some people that are familiar with these drives, and I need to do a lot of reading to make sure that I don't do something that is unrepairable. So, oof, big oof. It's going to be a rough day, but we haven't given up yet. So we'll get to work on it, and hopefully I'll have a good update for you in a bit. All right, it's been a few days. I've talked to some people. The more we thought about it, the more we looked at it, I reviewed the footage. It sounds like a head crash. Multiple people have listened to that and said it sounds just like a head crash. But there's really only one way to know for sure. And so I figured that the first step would be to try and get a look at the spindle motor from the back, since that didn't involve cracking open the top. And in order to get to that, we need to get the shield off of the back of the drive, which is just held on with 4 screws. That gives us access to the PCB, which has another screw right in the center. Once that's loose, the PCB kind of peels away, and that gives us access to all of the cables that are connecting it. And here in the back, there's 3 ribbon cables, and one of them is just that atrocious type that plugs in with the pins that kind of stab. But with that out of the way, we can get the PCB out and on the bench. And CDC, you are insane, because this is a ridiculous level of engineering going into this PCB. But with the PCB out of the way, we can get to the back of the motor, almost. The next thing we have to do is take off the grounding strap, and with that out of the way, we can get to this little plastic piece here. This is a fan, as well as the drum for the brake, and it has notches cut out in it so that these sensors over here on the right can actually read what's going on. I don't know if it's for reading RPM or something else completely different. But with that plastic piece off, it's just held on with 4 little screws. we can finally get a look at the back of the motor. And well, it's a simultaneous good news and bad news, because the back of the motor looks really clean. Nothing seems burned up. There's no scorch marks on anything. And the motor seems to spin really free and easy when turning it by hand. So the next step I figured was to put it all back together and spin it up one more time, just to see if the sound had changed by me getting in there and shifting things around by hand. So I plugged it all in and spun it up, and this is what it sounded like. Yeah, that's not a good sound. That's really bad. And the microphone actually dulls the sound down a little bit. It's even more gravelly and gross sounding in person. And so, I don't know, maybe it's the motor, maybe we actually have a head crash. The only thing is that I can confirm for 100% whether we had a head crash or not by just looking at the platters. But that requires pulling this opaque cover off of the top, and that is very likely to kill the drive, because this drive is built much like a modern hard drive. It was constructed in a clean room, so that way when they put it in, not a single speck of dust can find its way into the enclosure, and opening it up not in a clean room pretty much invites dust and will kill the drive, because just the tiniest speck of dust can cause a head crash. But also, we're at a point where the drive is pretty much unusable. There's not a whole lot left we can lose, because it's really just a very pretty paperweight at the moment. So it was not an easy decision to make, and I'm sure a lot of people are going to disagree with me, but I think it was time to open it up. So the first step was to pull this PCB off of the back. It was held on with 2 screws and a little ribbon cable. Once that was out of the way, I got access to the clips holding the opaque enclosure on. Getting those off just required prying them off with a screwdriver. And once those were out of the way, it was time to crack it open. Now, I tried to take as many precautions as I could. I wore long sleeves, I had rubber gloves, I put my hair in a hat, I turned the air conditioning off, the air in the room was dead still, and so I very carefully used my screwdriver to pry open the top, cracked it loose from the seal, pulled it off, and got a look at the platters. And, well, good news, bad news. The good news is it doesn't look like there was a head crash. Looking through these photos, I can clearly see the reflection of the spindle off of the platters, and I don't see a stripe or a line indicating where a head might have crashed, especially one as severe to have caused such a loud sound. Bad news is that as soon as I cracked it open, a ton of dust flocked into the machine. So now there's a bunch of dust sitting on the platters. That will definitely ruin the drive. So in an effort to determine whether the drive was ruined or not, we may very well have ruined it. But well, at this point, we can either give up or we can keep pushing forward and maybe we'll get lucky. I don't know. So I took a can of air and I sprayed off the platters, trying to get every speck of dust off of them. And as near as I could tell, to my eyes, they were spotless. There's not a single speck of dust on any of the platters. Now, of course, I am a human and my eyes are not that great. And I'm doing this not in a clean room, so the chances that they are completely spotless are not great. But, well, let's just keep pushing forward and see where this takes us. So I put the opaque cover back on, and that's where it sits right now. Now I do have the heads locked in position, so they're going to be stuck over the landing zone. And I think we should try to spin it up, because who knows, maybe taking it apart and moving stuff around jostled something back into place. Also, I want to spin it up because with the heads locked, there is a chance that the centrifugal force of the platters spinning will push off any dust and get it to rest at the bottom down here. And I say rest because there is no airflow inside of this enclosure here. Unlike the Hawk, which uses positive pressure within the platters to both float the heads and get any dust off of the platters, there is no fan, there is no airflow, there is nothing going on inside of here. There is just a little filter over in the corner that acts as a pressure equalization port. So let's put some power onto it. I'm going to take the mic and put it as close as possible to it so we can hear what it sounds like, and maybe we can compare audio files to see if there's been any changes in the sound with the, well, just exploratory work that we've done. All right, I'm more confused now because that sounded brilliant. That sounded perfect. That sounded exactly like it's supposed to sound. There was no gravelly or gross humming or grinding going on. It was just smooth and perfect sounding, honestly, which is both perplexing and awesome and terrifying because I have no idea what's going on, and it's terrifying in that if I put dust in the system and that's going to cause a head crash and it was really something else that was trivial, I'm going to kick myself. But it sounds great now. However, the heads are still locked in position. There's really only one way to know for sure, and that's to unlock the heads, spin it up, and let the heads fly out to track 0 and give it a listen from there. Now, if it does spin up, this is a huge if. I don't know what's going to happen, but if it does spin up and it does not crash and it sounds normal, there's a lot of ands and caveats here, a lot of prerequisites, but if we get all the way up to the point where it's flying over track 0 and it sounds totally normal, I want to check for the byte clock. Now, before all of this happened, I started trying to trace out where the data was coming from and where the byte clock was coming from, because this is a soft sectored drive. There's no hard sectoring or hard-coded information going on. Everything is written to a platter. So in order for us to get a byte clock, it has to be reading off of the platter. And that's actually something that I've seen before. I did some testing. We have a 75110 line driver that, interestingly, I think is bad because the output out of it is not differential and only 1 volt peak to peak, but the input going into it is our byte clock, and it actually looks like a proper byte clock. If we spin it up and it sounds good and it's sitting over track 0 and everything looks to be copacetic, I'm gonna check this pin to see if we get a byte clock. And if we do, fingers crossed, maybe that means that the drive is not thrashed. So this is really nerve-wracking. So I'm gonna turn the oscilloscope on just in case. We'll unlock the heads, spin it up, give it a listen, and then hopefully things go well. Well, that's good news, I guess. The heads flew. It sounded totally normal. I didn't hear any screeching or scratching or zinging or anything that would indicate a head crash from the heads picking up a piece of dust that may have still been on the platters. And once it was floating over track 0, I was able to get a read on the byte clock. So maybe crisis averted? At the moment, it sure looks like at the very least, the head that's sitting over the servo platter is not crashed and reading fine, because we're getting our byte clock and it doesn't sound gravelly and gross anymore. I have absolutely no clue what happened, if it will happen again, or why. The best I can think, the best theory that I have is that we had a pressure differential between the inside of the enclosure and the outside. The last time I spun this drive up, it was summer and it was outside in the garage. And now it's winter, the air is a lot denser. So maybe we had a relatively low pressure inside the enclosure, and that was causing the outside dense atmospheric pressure to push on the bearing in the hub and slightly unseated it. And when I cracked the enclosure loose, that allowed air to rush in and the pressures to equalize and the bearing to go back and settle. Now that should never happen, because that's what the pressure equalization port is for. And looking at it, it doesn't look like it's clogged or anything built any nests in it or anything like that. But that is really the only thing that makes sense. Maybe it took me knocking on it and hammering on it to get these clasps back on to shake everything into its place. But I can tell you right now, from this moment forward, this drive will never spend a day on its back again. It will forever sit on its side. I'm gonna put a big note on it that says, do not lay flat. But for today, I'm gonna quit while I'm ahead. Maybe. I'm gonna quit while I got back up to the point we were at the beginning of the episode. And in the next episode, we're gonna start trying to figure out what's going on the PCB, because like I said, I'm pretty sure we have a bad line driver at a minimum. But for today, I'm just gonna go sit down, put my feet up, and just breathe easy for a little bit, because the last few days have been pretty stressful. So I want to thank you guys so much for watching, and I hope to see you in the next episode.